What's happening, folks? Geologist Philip Prince. I want to talk some more about Helene's landslides today, specifically the debris flow landslides that the extreme rain associated with the storm caused. What you're looking at here is a bunch of debris flows in Yancey County, North Carolina, very close to the Pensacola community. What you see on this mountain is representative of a very large portion of Yancey County and many other counties of Western North Carolina, where with the sufficient rainfall and the topography, debris flows were very common with this storm. What I want to do in this video is use LiDAR imagery along with that satellite imagery to show the areas in the landscape that debris flow landslides can start and the areas in the landscape that they follow on their path downhill. It's a particularly mobile type of landslide. You hear it called a mudslide in the news. Like I say in all these videos, there's boulders and trees coming along with it, so it's much more damaging than mud alone. But it's a type of landslide that requires very extreme rain to occur, and it's a type of landslide that follows the topography down slope like you can see here in this satellite imagery. It's almost like the debris flow went down the mountain just as water might, and that's exactly what happened. So it's a phenomenon that is possible to understand in terms of its movement. You can't predict exactly where one will happen or which rain event will cause one in a given place, but conditions that are favorable for it are absolutely understandable. And where material might go down slope is also something that is very understandable in today's world with good mapping. And the reason it's important to talk about these slides is what you're about to see here as we zoom in. If I fade this satellite imagery away, you can see one, two, three, four, five structures in this little cleared area. I don't know if these are houses. They look like houses in the Google Earth imagery here. And if you bring that satellite imagery back in, that brown area, which is the debris flow's path where it actually went over the landscape, that sits right on top of those houses. It's a bad thing to see. Usually, when you see that with an event like this, there was a bad outcome associated with it. Now, does this video mean you shouldn't live in the mountains? Everywhere in the mountains is a disaster waiting to happen? Absolutely not. And it's important that you keep in mind that's not what this video is trying to say at all. What I do want to communicate is that under certain conditions, you can see something like this happen. It's happened before. It will absolutely happen again. You don't need a Helene to cause debris flows. 5 or so inches of rain in 24 hours, depending on how wet the weather has been for a period of time, can be enough to start one. And if you live in a place that has the potential to be affected, it's something that you need to keep in mind. But ultimately, this is a phenomenon with particular circumstances that cause it. And as you move around this landscape, you see areas that are tree covered. There's areas that actually lost a lot of leaves here, presumably due to some of the wind. With Helene, this imagery is kind of early fall, and you're starting to see some changes in the landscape. But you want to look beyond that tree cover and actually see what the lidar is showing here. Steep, what we'd call hollows, kind of these bowl-shaped, kind of concave areas high on the mountain here. Actually have some rock outcrops up here. That's going to shed a lot of rock debris. That's going to accumulate in those hollows. And with the right rain event, that can start that debris flow. It's going to come down slope and it's going to follow those channels for quite a distance. And that's what brings it into contact with the people down the slope, right? Kind of an additional detail here that's interesting. I can't confirm this. If we fade the LiDAR, if you look at where those debris flows start, sort of like it lines up with that old road grade that's visible in the mountains there. That's a thing that happens. Road embankments can fail during extreme rainfall and they can start a debris flow. Doesn't matter where the slide starts. It just depends how saturated the land is and how steep it is. And absolutely, all road embankments can start a debris flow sequence. So being able to see these details of the landscape and think about how they work is what understanding debris flow hazard is all about, right? I'm going to move northwest here, and this is the Tooties Creek area. again, very close to the Pensacola community there in Yancey County. And unfortunately, the debris flow that we're about to look at here did produce fatalities. It began high up on this peak. We'll zoom in and look at it here. Very close to the mountaintop, you got these rock outcrops, very steep, an area where debris has shed from those outcrops and accumulated many, many feet thick. There's a lot of this stuff sitting up there. Debris flow began and it followed this stream channel all the way out onto this sort of, again, conspicuously flat area in the landscape. Why is that flat? That's where material has accumulated from past debris flows over the years. I mean, centuries, thousands of years, who knows how long. But that means that this is a place that gets material delivered to it by debris flows. Let's fade that LiDAR away. And you can actually see just a little bit of the brown scar left by the flow. Its track is visible because the trees are missing. It looks sort of like that dark groove through the landscape. And then you can see a large brown area down here where the material actually deposited. And that, again, is always a difficult place to look after an event like this, because if we fade the overlay imagery away, you will see that there are quite a few houses exactly in that spot, that was impacted here. And this particular location is just sort of a classic example of an Appalachian valley that is hit by a big debris flow. People are living in that valley. It's a place that has not had an event like that for many decades, maybe centuries, maybe more. No one knows. It's not a thing necessarily that people even think about. The weather's bad. They're inside trying to get out of the bad weather, and that bad weather is what actually causes the debris flow event. So, being able to think about where you are in the landscape, maybe in ways that you never have before. That's an important lesson to take away from this storm and all of its countless absolutely terrible outcomes. I mean, it'll be years, generations before we stop talking about this. But of things that you can take away from it, it's important to remember that the mountains look like they do for a reason. It can be a dynamic landscape. And when you think in terms of what is above me, what do these, unusually flat areas along streams mean? How did that material get there? Could that happen again? It's something to have in mind, and it's something again that's not an everyday thing, but it could be, going forward from this point. Want to try to show a few more examples. I'm gonna head up to Watauga County here. Briefly, we're going to look at this time. Pretty well documented after it occurred. There's a fella doing, I want to say it's like Jaybird aerial photography. Actually has some very useful drone footage that came out early on after the storm. And this area is along, I think it's Vanderpool Creek. I know Vanderpool Road comes up in this valley. Fade the LiDAR out there. The red roof there, I think, is a school here. And there's your big debris flow coming down the slope. So if we spin it around, see the scar it left coming down the hill in this sort of brown area where all of the material spread out onto the valley floor. This is an interesting example because, first and foremost, it fits that overall topography that tends to make debris flows very nicely. You got some rock outcrops up here. Material from those has accumulated on the slope. It's kind of a concave, bowl-shaped, hollow area high on the slope. The flow can start there and come downhill. But in this case, instead of completely following this little stream channel, it actually sort of, I've used the expression, jump the tracks, so to speak. I mean, debris flows are very fast. And instead of coming down here and just staying in that channel like that, it was actually able to kind of almost spill out and produce this huge deposit of material out on the landscape. And if you see the aerial images of this one, it's really something else, because that deposit stops right behind the house. It's like a white house, I think, that you can see pretty well in that drone footage. And if we fade this imagery away here, We can actually zoom in, and see that particular structure. Again, if I'm not mistaken, see that the hand right down there. See if we can circle that here on the screen. Uh, I think that is the house that ended up with the debris flow full of trees, boulders, all kinds of stuff, literally touching the back wall. The little stream channel, veers away in this location. So this is an area that maybe right off the bat you say, well, I'm not in that stream channel. Maybe it's not a problem for me. You have to keep in mind that it's possible for material to move with enough momentum to spread out like that, right? So understanding debris flows is not just thinking about where the water would go in the landscape, and then just using that to inform your thinking. You have to understand that they're a little bit different than just flowing water. There's so much mass involved. There's so much momentum involved that they can behave just a little bit differently. But for the big picture, if terrain like this is above your house, and you're near a little channel like that, and you're about to have a absolutely epic rainfall, inches, inches, inches upon inches in a pretty short period of time, you would want to be thinking about that and thinking about maybe a place that you could go to. It doesn't have to be far away, just something that's a little bit out of the reach of material moving with gravity here. And to look at this overall landscape, steep mountain, hollow area here, big flat area where material that has come down off of that mountain has accumulated. Absolutely classic debris flow setting here in the Southern Appalachians. Take ourselves down to the Swannanoa area now. The north side of Swannanoa in particular, not the biggest mountains in the vicinity of Asheville by any stretch. Probably a place that residents, the idea of a debris flow there may not have been something they'd ever heard of, but it was very, very strongly impacted, to say the least, by Helene here. You had the flooding down in the valley, and on the mountains here just north of town, equally catastrophic events coming off of the slopes. One that really jumps out is a huge, long debris flow. It's about 4,000 feet long. It's 3/4 of a mile long. This one started up on the ridge. It's a natural slope up there. You might say that it even resembles the ones in Yancey County that we started out with there. You got these rough rock outcrops, areas that material falling off of those outcrops can accumulate. The failure starts there, and then it's just going to make its way right down this channel. This would be a tiny little creek here, and then it's going to encounter this flatter topography where the old debris flows have deposited their material over time. So if you're seeing a pattern here, good. That's sort of the point of this video. It's sort of like it's a big thing in geology, is just trying to recognize patterns in what otherwise might look kind of like a disordered landscape, right? There's human-made patterns that are extremely orderly, and then in the natural world there can be patterns that are a little bit less obvious. But when it comes down to slope stability, and what we're talking about here, yes, there is 100% a type of landscape that you really have to look very closely at, in terms of understanding how it might work. And this is probably a good type to hop out to draw a diagram up here, because the shapes you're seeing here, where the debris flow might start, how it might make its way downhill, that's something that you can sort of read out of the landscape. So if you again asked a geologist, where might you expect this hazard? Somewhere up here, we need to use a brighter color than that here. Somewhere up here on these steeper slopes, okay? And the debris flow, of course, is going to follow that channel, and end up coming out something like that. And that is what happened here. So if you can read that signature and think about how materials move, you have a better chance of understanding what could happen, right? So we'll hop out here, get this thing sketched up, and then come back to the maps. Okay, so doing the drawing here after the fact, I wanted to be sure that I knew exactly what I should illustrate in this one to be sure it matches up with the content in the video when it was all said and done. Going to use a similar style to what you've probably seen already on this channel, but want to be sure I work in a few extra details here that are going to be pretty important to understanding where you might expect these debris flows to begin when the weather's right. Can't emphasize that enough. This isn't an everyday type of thing. This isn't an every time it rains type of thing. This is associated with big rainfall events. And in many cases, I mean, you're going to know that something like that is coming, and that could be your cue just to be aware of how things are progressing if you find yourself in a place that might experience debris flow landslides. Right, so I'm going to build in a couple of these hollows here high up on the slope and leave a few areas mixed in there where you might see some of those flatter areas that end up kind of matching up with the adjacent steep slopes. Those are trying to communicate that there's spots where material derived from the slope, that colluvial soil, probably ought to write that on here, has been able to accumulate below those steeper, higher areas. And where that colluvial soil accumulates, that's where you might expect debris flows to begin, particularly because of the shape of the slope. It's going to have kind of a concave sort of bowl shape, and the steep sides that are already there to begin with, right? So it's a place that instability is not unexpected. And right here in this area, try to also add in what's going to be kind of a little channel cutting across this flatter area that I've drawn in. And that flatter area, again, is something that you may have seen so far in the video. That's one of these big accumulations of deposited material. And I'm trying to add some details here, like what I just did, so that I can put things like that Vanderpool slide in Watauga County into a little bit better context. Variety of landforms here distributed throughout this landscape, as we might expect to see in various parts of the Appalachian Blue Ridge, which was the area of the Appalachians that was so strongly affected by Helene. Get us a few little streams running down this. Hesitant to use too thick of lines here because I want to be sure that I have enough room to emphasize how the slopes and their shapes are going to control what's going on. Right, so got a couple little streams coming down the mountain there. Got another one coming down here. It's going to be using that channel to get across that flatter area. Got some making their way down, starting up these really, really high elevation steep hollows there. And we'll add even a couple little tributaries coming out, something like that. Right. So now we've got our landscape here. Got some landforms on it. Last thing to try to build in here maybe is a little bit of that outcropping bedrock, really, really, really high up here in the landscape. And those are those outcrops that are going to be shedding fragments of rock, boulders. Those are going to pile up in those hollows down below it. And that's that stuff that you got to think about when you have one of these events where it rains 5 or so inches in 24 hours or more. Those are the conditions to be aware of, right? Okay, so couple more outcrops here, just a few separate places. Where are people going to live in this landscape? Well, living along streams, of course, is always popular. Some of these flatter areas that are deposit material can be quite popular to live on just because it's flatter land. So you've got something like this down here. And, many places at the foot of the mountains, of course, can be inhabited. We'll put some folks up on this kind of spur ridge here. Well, even a couple up here at the top of the mountain. A couple more to add in here. And this is probably going to be good enough for what we're trying to illustrate here, I would think at this point. Okay, so there's our framework. Where are the debris flows likely to happen and travel in this landscape? Here's a spot right up in this big hollow. Might need to use a slightly larger line width there. And so that's going to come down and just follow that channel all the way down. That remains nice and channelized the whole way. That would be a very dangerous situation. Okay. If you're along that stream and that's above you, that'll be a bad one. We'll start another one off over here. It's going to come down that channel. Those structures may be at risk. The ones right along the stream down below are at a very, very, very high risk from a situation like that. Even the ones here that are a little bit away from that channel, you could start something up here on the cliffs. It might not go as far. That's also a potential hazard, right? we'll start one off in this channel. And this is going to be sort of the Vanderpool-like example. If it's going fast enough, it's going to, sort of jump the tracks there, so to speak, and actually come up out of that channel instead of following the bend in the stream channel. Term for that is super elevation. And that is absolutely a thing with debris flows because they can go 40 or 50 miles an hour, depending on the topography, right? Don't even need the big topography here necessarily to have a debris flow. Say you had a house up this small stream here. You don't have those big cliffs up above you. Seems like a lower energy part of the landscape. Depending where you are here, you can absolutely have an issue. Say you start one up right here, and you could have a problem there as well. It doesn't have to be a big debris flow to completely destroy a property, right? The density, the velocity, it's a problem at any scale. Now, looking elsewhere, same type of thing. And again, of course, what you have seen in this video thus far, this one's going to follow the channel down. And again, down here at the bottom, depending how it behaves in its lower reaches there, you have the potential there for very bad impacts. Where are impacts avoided in this situation? Well, we'll circle them in red there. So we got something down here. This is sort of in line with a topographic spur. Okay. This area here is sort of in line with a topographic spur. The folks here up on the ridge, not a problem there. Even at the small scale, sort of a smaller topographic spur there. Folks maybe not in the best place in the landscape, but if they were at the mouth of this hollow here, that is a place that could have a debris flow impact, right? So large scale, small scale, you have to think in both terms, but fundamentally, debris flows follow, they follow water channels, right? And if you have terrain above you that looks like that has those, we'll emphasize them a little bit more here, that has those kind of steep outcrops, material accumulating up there, and you're in line with it or connected to it sort of by a channel network, that's absolutely a place to think about. Now, does that mean you can't live in these places? Absolutely not. Does that mean you should flee the mountains? Absolutely not. You just have to be aware when extreme weather conditions are present. All right. 5 inches, 24 hours. Yeah, that happens a fair bit in the Appalachians. Some years it doesn't. Some years it happens many times. If you know that's coming, be aware of it and plan accordingly. And I would imagine after this event, we will hear more about that when extreme precipitation is predicted. Right. So we'll hop back to the maps now. Okay, so hopefully that gives you a better sense of what these landforms might look like in practice. We're seeing it with LiDAR here is not an everyday thing, but being able to look at the slopes and visualize where you might have instability high up and how that instability as a debris flow might travel is an important thing to think about. And if you look at where this big flow went, yes, that impacted structures. You got Owen High School right down here. I don't know exactly what this building is associated with here. I think it's called Shepherd Hill or something like that. One way or another, there were structure impacts here. Don't know the outcome there. Said at the beginning, if you see something like this, usually the outcome is quite bad. You can see the scar of this quite easily from down in Swannanoa, from down on 70. Moving over here to the southwest or west just a little bit. Another area that was very hard hit by debris flows. Want to particularly point out the one. Let me see right here. I'll try to circle this one. Let's see. So you can see something like that right there. If we take the overlay away here, and it may take me a moment to find the right one to actually fade away. I got so many of them. There we go. If you look inside the circled area, there's a lot of structures here, all the way down. Absolutely no question that this one impacted structures. And I believe, I don't know this for sure, I think this debris flow actually may have led to fatalities, unfortunately, as well. And just being such a populous area, it would be difficult for that not to have happened. Bringing the LiDAR here, this isn't up in the steepest part of the landscape where there's a bunch of outcropping rock up there. In fact, this is a mountain for sure, but it might again not be one that you ever thought of as potentially as dynamic as it was during Helene. If we fade that LiDAR away, another interesting detail to see is that flow looks like it might have started somewhere up around where this road grade comes across the landscape. Just enough to start a sliding. Maybe the drainage is a little bit different up there or something like that. And when it's that saturated, all you need is something to get it going, and it's going to follow the topography all the way down. Everything that the hand is moving around on now, all those flat pads, that's where structures were, right? So it's a bad situation here for sure, and one that you would probably only have to think about once every few years, if not once every several decades. And when we have a storm like this, unfortunately, that's one of those times, and it can be difficult to bring all this to mind very quickly because it's not an event that's happening all the time in this part of the Appalachians. And fading that LiDAR again and zooming back out, I mean, this entire area is absolutely full of smaller debris flows. You can see some in the background here. This area, again, north of Swannanoa, obviously had absolutely catastrophic rainfall. That was a contributor to the extreme flooding, of course, in Swannanoa. All the way back here, you can see Tree Reservoir there with debris flows that actually went directly into it during the storm. And much like North Fork, that's a place that's going to have now turbidity problems in the water. And when you see rainfall going forward, it's probably going to, continue to add a lot of mud and fine sediment down here into the lake. Where did those debris flows that went in the reservoir come from? Got the cliffs up here, got that big bowl-shaped hollow kind of place, materials accumulated. Absolutely classic setting yet again. Last one wanted to check out here. Head over towards sort of the Fairview area. And this is going to be just above north of Old Fort Road. Get the image tilted up here just a little bit. Over here toward the right of the screen, you can see the initiation zones and the tracks of the Garin Creek debris flows I talked about that impacted the Craigtown area so catastrophically. Pretty much all of the Swannanoa Mountains here had debris flow impacts just because of the extreme rainfall, and a couple of them here, like the one got the hand circle in there in particular, obviously had impacts all the way down to Old Fort Road here. So we're going to zoom in, take a close look at this one. See Old Fort Road coming across. Let's see if this is the right overlay. It is. Okay. So that's Old Fort Road. You got structures here. I don't think those are houses. Those look more like kind of barns or agricultural buildings. You have houses, though, quite close by. Bring that imagery back up again. And we'll actually try to draw that lower debris flow track onto the screen here. So it's coming across, and it looks like it did something like that. Okay, so let's see what that looks like on Google Earth. Looks like maybe it threaded the needle between these houses. There's one upslope here. I don't know what might have happened there. It does look like it impacted all of these structures here. Let's bring in now the LiDAR imagery and see where that sits in the landscape. So same thing we've been talking about here. It's absolutely possible to have a pretty good idea where those debris flows are going to go, and they're going to follow those stream channels. And you can of course see this one kind of coming down the mountain from the top there. Right. So knowing all of this, again, does that mean, well, I shouldn't live at the bottom of a mountain? No, doesn't mean that. Should I be afraid every time it rains? No, doesn't mean that either. Just be mindful of the fact that extreme rain, particularly during a wet period of time, has the potential to cause an event like this, and you can have some idea, where that's going to go in the landscape. Like I said during the sketch there, you're going to hear more about this at least for a while. I'm very confident of that, just because this was such an impactful event. It's going to be something that people need to think about, going forward. Go up to the top of this debris flow that went to Old Fort Road here. Maybe take a look at where it might have started. Fade my LiDAR back away here. Huge scar on the mountainside. Easy to see that one for sure. Get it centered on the screen. Bring the LiDAR back in. And it looks like that one actually might have started on an old logging road embankment there as well. Haven't been there, can't confirm that to you. Just because it appears to sit there, it could have started on the slope below it. It could have started on a natural slope up here and crossed that. Okay, so that's something you'd want to confirm in person, but it's an interesting connection, and it's something that I've actually personally seen in this area, looking at debris flows after this event for sure. We make our way here to the northeast. I mean, there are logging roads everywhere. I mean, just like any mountain in Blue Ridge, Appalachia. Timber harvest has been a big thing here for generations. That's not something that you're ever going to get away from on these slopes. And those old road grades have been there for a long time. They just haven't seen a Helene type storm. One more flow to look at here. Starts way up on the mountain, takes a really long path downhill, and it surely looks, and I don't know this for sure. Let's see if we fade that one away. It looks like that path taken by the debris flow also comes all the way down to Old Fort Road there. Very long. That one might, go 3/4 of a mile, something like that. Wanted to look at this one in detail. Haven't really even done this yet. Going to fade out some of the imagery there, and we'll bring that back in and trace it out real quick as well. Okay, so we got, looks like the track kind of comes around something like that. And let's see how that sets up in Google Earth. That one also looks like it might have, hopefully, passed right between a few of these houses that I'm pointing out here. I don't know if that might have been an impact there. I don't know if this house might have been impacted there either, but it's a similar pattern. And if we get rid of, we'll actually leave those drawings on there. We'll bring the LiDAR up here real quick. So same type of a thing. You got the channel coming down there. The debris flows following that. It gets to this flatter area, and it starts to spread out. Okay, so that's kind of the takeaway here from this video. You can have some sense of how this is going to work. You can have some sense of where these are going to move in the landscape, and if the conditions are right, you need to be aware that it's something that might happen. Conditions aren't going to be right very frequently, and we hope that they don't become more frequent. But one way or another, you're going to know, if weather conditions are trending in a way that might end up producing debris flows in the landscape. So when you look out over the mountains, you have to keep in mind that they look that way for a reason. Steep topography is always more dynamic, and it's something to be aware of. But no, you don't have to live in fear of it. And I don't think that as maybe communication gets better here, I don't think anyone's gonna try to say something like that, because that doesn't need to be said. All you need to know is that it's a thing that can happen, but it is so circumstance and weather dependent, that it's something that can be anticipated to some degree. Right now, if you're in a place that is potentially threatened by this possibility, say you live close to one of these channels coming down off the mountain here, what do you do? Probably a subject for another video, but you need to end up in a place that is less likely to see an impact. So, kind of like along this spur ridge here, debris flows are not really going to be that much of a thing up there. Okay. Something like this over here, way down in the valley here, it gets harder to tell where flows might go. But where there is slope in the landscape, these kind of hilltops and things like that, the hazard is going to be much reduced there, right? So there's always going to be places that will be safer if something like this is going to happen, and that probably almost needs to be its own video going forward. So hope you found this one interesting. I'm seeing more and more about these debris flows that occurred with Helene in the news. It seems like people are picking up that it was a very significant cause of fatalities, unfortunately, and it produced a tremendous amount of property destruction. Will we see something like this again anytime soon? No one knows for sure. But I think at this point, if we get to thinking about it more, it's possible, certainly, to reduce the bad outcomes. So we'll try to keep another video or two coming along. I need to get one going from down in Henderson County, southern Henderson County, a place I hadn't heard that much about. That was very strongly impacted by Helene as well. So hope you found this one useful, and hope you'll check out the next one.